Okay, in this video we're going to look at something called end behavior, and it's actually exactly what it sounds like. It's what happens in the ends of the graph. So how does the graph behave at the ends, meaning at the plus infinity and the minus infinity along the x's. So it asks what happens when x gets really big. Okay, so really big in the plus direction and really big in the minus direction. So we say for x very large. Okay, and remember in math we can make large and small pretty much whatever we want it to be. So we can make this very, very large if we want. So for this we're going to look at the multiplied out form, even though for the rest of this we're looking at the factored form. It's a little bit easier for this part to look at the multiplied out form. So let's say that we've got something like 3x to the fifth plus 4x squared minus 10x plus 4. Okay, so we've got the multiplied out form. The part that we're really interested in is this first term, because what happens when x gets really, really large, and you could maybe pull out a calculator and play around with this a little bit, but what happens is when x gets really large, and we're talking about like into the thousand, we can go 10, 100,000, 10,000, 100,000, million. What happens is that the rest of these terms are relatively small and they don't change the numbers very much. This term is the one that really matters when x starts to get very large. Okay, so when x starts to get very large, these are so small they don't really matter. The first term starts to dominate, and the graph pretty much looks like 3x to the fifth. Okay, so as x gets very large, what happens is the graph starts to look like its power function. And we can say ax to the n, or anx to the n. Okay, so the very first term, remember from our writing that out earlier? So it starts to look like the first term. So the number out front doesn't do too much. Remember, that changes the shape a little bit, but we're just looking for the arrows on the end. What we really want to know is that it's positive. Okay, the sign that's out front is positive, and what this exponent right here is. So for this one, it's positive and it's degree 5. So remember, in the multiplied out form, it's the largest exponent. So it's degree 5 and it's positive. So it's going to look like an odd power function, and positive means that it's facing in the normal direction. So the ends are going to look like a cubic. Okay, this doesn't tell us what's going on in the middle. The other stuff that we did tells us that. This just tells us the arrows. And then if we have, let's say, negative 2x to the 7th plus 3x to the 4th plus 2x minus 8. Okay, really, I'm just making these up because they don't really matter too much. What we care about is the one out front. We're looking at this one up here. If we want to talk about the end behavior, we want to look at the degree, and we want to look at the sign that is in front. So for this one, it's degree 7, and it's negative out front. So it tells us it's going to look like a cubic because it's odd. And the negative is going to flip the arrow. So it's going to go up on the left and down on the right. All right, and let's look at another one. Let's say we've got f of x equals 5x to the 8th minus 2x to the 7th plus 3x to the 4th. Okay, so again, when x gets really, really big, it's the first term that's going to dominate. So we're looking at the power function 5x to the 8th. Okay, the rest of these don't matter as much. So we're looking at something that has a positive coefficient, and the degree is 8. Okay, so degree 8 and it's positive out front. We know that degree 8 is even. That means it's going to look like a parabola. So the ends are going to look like a parabola facing up. Okay, so parabola facing up. And then our last possible scenario would be, let's say, something like negative 7x to the 6th plus 4x to the 5th minus 9. And again, we're going to look at the first term, looking right here. Okay, so that's degree 6. That's our highest exponent. And be careful if they're not in the right order, but we're not going to look at them too much in the factored form. So we're degree 6, and we have a negative out front. So we've got even degree, and a negative out front tells us that it's like a parabola facing down. So our two ends are going to face down. Okay, and these are the 4 possible combinations. You either have degree that's odd or degree that's even, and it's either positive or negative. So if it's odd, it looks like a cubic facing up or down. And if it's even, it looks like a parabola facing the same direction, up or down. Okay, so when it's in factored form, these things still applied. It was just easier to look at it when it wasn't factored, when it was all multiplied out. But when we put it all together, we'll be looking at it in the factored form. We'll be looking at the degree and whether the leading coefficient is positive or negative.